Our next topic that we're going to talk about is an introduction to autonomous. We're going to start with some pretty simple time-based routines. This is something that's already written for you by FRC in this specific getting started example. So like this says, what this does essentially is it drives forward for 2 seconds, half speed, and then it stops the robot. We are going to see if we can make it do something just a little bit more complicated, so that way we're the ones writing the code. Let's just make it go in a square. So it's essentially going to do the same thing 4 times. We'll just give us some more space in here. We don't really need it to go that far, so we'll just do 1 second. So what this does is this is going to get your time, and that time is going to be given to you in seconds. So this is going to say, as long as the time is under 1 second, then it's going to do whatever is inside this body over and over and over again. That's what this periodic means. So it's just going to keep telling it to drive forwards at half speed until it's not that, and then it will do the else, and it'll stop the motor, and it'll be done. As we're going to want to add some else ifs instead of just else's. So we're going to do the m_timer again, and then we want to get that value. And then since that one was less than a second, then we're going to want to turn. We're just going to say a second again, and we'll just play with our times to get stuff to go the way we want it to. What I did there was I just closed this statement right here. So this is the body of this else if, and then this else opens up and closes here. So just kind of fixing the stuff that I moved around earlier. So we're going to use the same thing, m_robot drive dot arcade drive. So if you see here the x speed, that's your forwards and backwards, and your z rotation is your turning. Our x speed right here was 0.5. So if we're going to turn, we probably don't want to go forward at all. So we're going to set that to 0. And then let's go ahead and turn at, we'll just say 50% power and see what that looks like. And it might be a little faster than we want it to. So now we're going to go ahead and close that, and then we're going to just add another else if. And actually we want this to go for another whole second, so we're going to do 2 seconds. So that means for the first second it's going to be doing this, and then after that first second up until that second second it's going to be doing whatever this is. For this next part we'll do a timer again, and then as long as this is less than, since we did a second before, we'll do a 3.0. Whoops. So we're adding on another second. Just because if we're trying to go in a square, we're going to want these to be even. So if we were going for something else, we might want to add more time, or maybe go a little bit faster and just see how that makes the robot behavior change. If we go do the m_robot drive dot arcade drive, and then this time we're going to be wanting to go forwards again, so we're going to go 0.5, and we're not going to want to turn, so that's going to be 0. And then we're just going to copy and paste this because this will make it a little bit easier instead of rewriting all that out. So we're going to want to add one more. So now we're going to go to 4 seconds. And we're going to be turning again right here. So that's going to be 0. And this is going to be 0.5. And we can paste again. And then 5 seconds, I think. So if we start, we drive forward. Then we turn. So let's drive forward. This is turn, half speed, and then drive forward, and then turn, and then forward again. This should be a complete square if I am not mistaken. So we have an extra bracket here. Make sure whenever you code you indent too, because it makes it easy to see if you're missing anything. Whoops, too much. So I'm not 100% sure. Again, you should be testing this for the first time on blocks, just to make sure everything's going. We're going to go ahead and build this again, make sure we're connected to our robot, which right now we're not. So we're going to go ahead and connect that. Now, there's something else that if we remember when we went down here, our Y's were backwards. So we're using the same thing here. So if our Y's were backwards, then we might want these to be negative. So right now, when we're going forwards, I think that this is probably actually going to drive backwards instead of forwards because our other stuff was backwards. For now, we are just going to make these, whoops, those are not the right spots. Yes, it is. Drive forward, and then forward again. So we're going to make those negative. So that way, hopefully, it's actually going forward instead of backwards. And we're not sure which way it's going to turn either. Positive should be to the right. So it should turn to the right and make a square when we enable autonomous. These speeds also might be a little fast, but luckily we know how to emergency stop if we need to. Again, you're going to be turning, and then the most important thing is when you're done. So once this is anything greater than 5, it should just stop this motor. We had a little hiccup with recording there, so we'll get back to what we're doing. We just built it. If we check here, we are connected, so we're going to go ahead and deploy it now. If we haven't, since this is the top one, it looks like we did already deploy it. So we are going to come back here. So if you need to e-stop, you can press space on the keyboard. So here's our robot. We're going to enable it in teleoperated mode first. So we will enable that, and none of our other stuff should go. We are going to put it, I think it's going to turn to the right. So we're going to try to put it somewhere where it's kind of out of the way. Since we're pretty sure the robot's going to go forward, worst case scenario it doesn't. Yeah, we'll have to see. I'm not exactly sure how this is going to react. This is why you should have it on blocks first. So now we're going to switch over to autonomous and go ahead and enable it. And the space bar is how to emergency stop it if it doesn't look like it's going to go the way we want it to. So we're going to go ahead and hit enable. Okay, so it is going backwards. And if you see it stop there, it's trying to turn, but it doesn't actually have enough power to do it. So we're going to have to make some adjustments. It did end up going backwards. It didn't do what we wanted it to. So we are going to get rid of these negatives because it's not turning as far as we want it to. We're also going to go ahead and bump this up to like point, I don't know, 6.5. Whoops, that needs to say 0. So we're just going to make it go a little bit faster going forward. And then on the turns, it didn't have enough power to turn. So we are going to bump this up to, we'll say like, I don't know, we'll do 0.65 here as well. And just see how that goes. Okay, so now we're going to build it again. And deploy. Okay, so we're going to go to teleop to move it away a little bit further since now it's going to be going a little bit faster. And then we are going to go to autonomous and we're going to go ahead and enable it and see what happens. So it goes forward and then it turns and it turns. Okay, so it didn't quite make it, and if you saw, there was some stuff that wasn't quite right. So it looks like the turnings either aren't quite long enough or we're not turning quite fast enough. So there's a couple things we can do. We're going to play with the power instead of the time just because that seems like an easier way to go about it. So since the 0.65 was enough, we'll go up to 0.75. Otherwise, I think the forwards and backwards were fine. So it also didn't make the whole square that we wanted, which is okay for now. So we'd have to add some more else statements to make it turn again. So there's also another pretty important thing to know here. As you can see, what we're doing now is based solely off of the power that we're giving the robot and the amount of time. But once we get further into this course, hopefully we'll start talking about using encoders and gyroscopes to more accurately measure our distance and to keep our robot driving straight as well as turning at like pretty exact angles. And we will get into that down the road a little bit. For now, we're just going to try to make this as close as we can. Almost every year, there's like just an autonomous line that you have to cross. So this is just kind of to show if you really just need to drive forward, like it's not super hard to do, and it's just a matter of a line of code, and you just need to make sure you only do it for so long. Now that that's built, and we got to deploy it. So we are gonna get it a ways away from us again, and just get it kind of squared up so it'll be a little bit closer, and just see what happens. Okay, so now we're in autonomous, and we are going to enable it. So the first, now I think it went too far. Maybe it went too far before and I just misjudged it. But you're kind of seeing what that looks like. Another good thing to do would be to give it time in between to kind of stop and adjust for when it turns. Otherwise, it gets really jerky like that. And that has to do with the robot having forward momentum when you're trying to turn. So if we were to slow that down or give it a little bit of time in between the different movements to kind of settle where it's at. And all that's a lot easier to do with sensors again, because you can have it be based off of time until it goes to the next step. So you can give it so much time to get so far, and then give it a little bit extra time to kind of settle and slow down, and then it'll start the next movement instead of trying to do it one right after the other. And that's why it was jerky like that. So that's all I have for kind of simple autonomous programs. Obviously, they can get much more complex, but since we haven't worked much with different sensors and stuff, we are going to wait on that for a little bit. So that's all I have for now. Thanks for watching, and we will see you in the next one.